What is a topology? Let's take an empty set X. Then a topology tau on X is a collection of subsets of X that satisfies these three criteria. Criteria number one, X, which is now the non-empty set, and the empty set is a member of tau. Criteria number two, the collection is closed under arbitrary union. This means that if you take two subsets in that collection of tau, then you find their union, that union must also be in tau. Criteria number three is the collection is closed under finite intersection. Same case to now what you have defined in the second criteria. This means that if you take two subsets, find the intersection should be a member of tau. Types of topologies. Number one, we have the discrete topology. A discrete topology on X is the collection of all the possible subsets of X. Number two, we have the indiscrete topology. This is also known as trivial topology, which is the simplest possible topology that can be defined on a set. It consists of only the empty set and the entire set, in our case, X. Number three, we have Sapinski's topology. This is a topology that is defined on a set of exactly 2 points where only one of the singletons is open. Now, let me explain what does the term open means. When I say an open set, it means a set that does not contain its boundary. Intuitively, every point in an open set has some breathing room around it. Now, let me give you an example. Recall how we present an interval on a number line. Say, for example, you have 0, 1, that is an open interval, meaning it is enclosed on open parentheses. So if you have 0, 1, the interval 0, 1, if it is open, meaning you exclude 0 and 1. Now the closed set is now the opposite. Is a set that contains all its boundary points. So you have 0, 1 as an interval, as a closed interval, meaning it is closed. It is enclosed on a closed parenthesis, and the interval is 0, 1, meaning including 0 and 1. Another type of topology is called a particular point topology. This is a topology which contains a pre-chosen point, let's call it P, and any other subset open if and only if they contain the point P. Stay with me. I know that may seem complex, but I'm going to explain it. The other type of topology is called a coset topology. This is a topology with the lowest number of subsets. The other one and the last one is a finest topology. This is a topology with the highest number of subsets. Let's take an example that will deepen that knowledge. You are taught to list all topologies on a 2-point set 0, 1. So you have to list all the topologies. Number one, and the first one, is the discrete topology. We said a discrete topology is the topology that has all the subsets. And if you recall on discrete, on how we find subsets of a set, you're going to be able to give the discrete topology. So we set a 1 will be 1 is the empty set, 0, 1, and the set itself, which is 0, 1. Number two, another topology is the indiscrete topology, which is the trivial subset, okay? So tau 2 is 8, the set itself, that is 0, 1, and the empty set. Number three, we have the Sapinski's topology, the open set, okay? I hope you recall that. So you're going to have the set itself, the empty set, and the open set in that set. Which is the open set? It's 1. I explained that a open set is a set that does not contain its boundary, so it is 1. Then number 4, we have the particular point topology. The one that is not included in those topologies is 0. So we say the tau 4 is going to be the empty set X, or the whole set is 0, 1, and 0. Example number 2, we are told to determine the quartet and the finest topologies on the set B, A, B, C. Now the quartet is the weaker topology, or the topology with the lowest number of subsets, and it is usually the indiscrete topology, meaning it contains the trivial set. So tau is the empty set and the set itself. So that's the quartet topology. The finest topology is the strongest, or the topology with the highest number of subsets. In our case, it is usually the discrete topology, meaning it is a topology that contains all the possible subsets of the set, or the X. Okay. Now, let me remind you how to find the subset of a set for those who forgot. In our case, we have B, and it has 3 elements. So even before we get to the subset, how do you know the number of subset you should get? You should take 2 power 3, meaning 2 power the number of elements in that set. In our case, we have 3 elements in B. So 2 power 3 is 8. So you should have 8 subsets. So how do you find them? One, the first part, it's an empty set. An empty set is a subset of any set. Number 2, pick the single element in that set. So in our case B, we have A, B, C. We have element A, B, C. So you pick A, B, C as separate set. So that becomes subset. Number 3, pick the pairs. So in our case, you can pick A, B, that is one set as a pair. A, C, that's as a set, as a pair. You can also have B, C, okay? Then you can go to quadruples if you have 4 elements. But in our case, because we have 3 elements, now you go to the full set. So lastly, this is going to be the set that we are going to have the empty set A, B, C, A, B, B, C, A, C, and the set itself.